Hey, good day everyone. My name is Sai Grishman Chakurpati and my research proposal is titled AI Assisted Failure Analysis and Automation in Embedded CGM Path Software Testing. The study investigates whether AI testing practices can improve software quality outcomes, testing efficiency, and engineer decision making. So, in the introduction part, I will walk you through the problem statement, which is generally, embedded CGM path software testing involves complex interactions between software, firmware, wireless communication, testing tools, and human interactions. So, whenever a failure occurs, engineer must determine whether if it is caused by environmental instability or software defect or tool behavior or timing issues. This investigation takes often takes more time and it is resource intensive. The purpose of the study is to evaluate whether AI assisted testing practices are associated with improved defect detection and better testing efficiency, reduced non-deterministic outcomes as well. So that is for the introduction part, and you can find the flowchart over here. Coming to literature synthesis, this literature shows that AI-assisted software testing has advanced significantly over past 2 decades and also improved automated failure classification using defect range for flaky test detection reduces uncertainty. The CA prediction supports efficient resource allocation and root cause analysis determines uh, failure causes that more quickly. Collectively, these studies demonstrate the growing role of AI in software quality improvement. However, most studies focus on individual testing functions rather than examining how these capabilities interact within a single device of software testing. So that is the base source for me for finding the gap. Although there are substantial researches in failure classification, flaky test detection, CI prediction, and root cause analysis, these are usually studied separately. So very little research and investigations are done on single context framework for CGM patch testing. Additionally, engineer interpretability remains underexplored. So these gaps are the reason for the foundation of proposed study and motivates the investigation of whether AI-assisted testing practices collectively contribute to improved software quality outcomes. For this study, for the framework and research approach I formed are the conceptual framework majorly integrates four testing practices that we have already discussed previously, which is AI failure classification, test prioritization, flaky test detection, root cause analysis. So one step after the other performs where each step contains different level of investigation and finally gives us the software quality outcomes. For this research project, I chose quantitative correlational approach because it seems to examine measurable relationships among naturally occurring test practices and outcomes without manipulating the test environment. So the research design and data collection and ethics. For this part, the study contains four research questions that examine relationships between AI tested practices and software quality outcomes. So this data will be collected from technical testing records such as existing logs, defect reports, and rerun histories, and as well as surveys completed by the software engineers, QA professionals, and integration testers as well. Ethical safeguards include informed consent, confidentiality, protection, and anonymization of organizational information. No patient identifiable or personal health information will be collected. For the conclusion, uh, I have listed out the references that I have made, and the main major significance is it addresses the literature gap, improves testing efficiency, supports better decisions, and also enhances the software quality. Thank you guys for listening.